Hello guys and welcome back to my channel Technical Interview. And today we are back with another important question for technical interview, and today's question is finding the median of a strings of running number. So without wasting much time, let's start with solving this problem of finding the median of a strings of running integers. So before going into the solution of this problem, let us first understand the problem. So in normal mathematics, the median of a particular set of numbers is considered as the middle number within the set if the set of the numbers are arranged in an ascending order. So for example, we are given a set of numbers like 1 to 7. And if I want to find out the median of a number, the first objective will be we have to sort this array in the ascending order. So over here, this array is already sorted in the ascending order. And if we want to find out the median of this set of number, we first have to see the size of the array. So over here, you can see that the size of this array is 7, which is an odd number. So if the size of the array is an odd number, the median of this set of number will be the middle number of this array. So over here, the median of this set of number will be 4. Because over here we can see that we can distribute this array into two equal sets, one consisting of 1, 2, 3 and another consisting of 5, 6 and 7. Whereas if this set of number would have one more number, for example 8 over here, and the size of this number is even, at that time the median of this set of number would be the average of the two middle number present within this set. So over here the median of this set of number will be 4 plus 5 divided by 2. So hopefully this gives the clarification of the term that what is a median of a set of numbers means. So if the size of the array is odd, then the median of the number will be the middle number, and if the size of the array is even, then the median of the number will be the average of the middle two number over here, provided with the condition that the array should be in the sorted order. So this is the basic mathematical calculation of how to find out the median of a particular array. Now let's go into this question and let's see what this question actually tells us. So over here the problem statement tells us we have to find out the median of a streams of number. So what does the streams of running number means? So in our previous example, you have seen that to find out the median of a number, we were first calculating the size of the array. But over here, there is a problem. The problem is whenever the problem statement is saying that a streams of number, which means that at the very starting of the program, we are not sure about the size of the number set. So over here, there can be a streams of number like 5, then comes 3, 2, 7 and so on. And this can keep on going for an infinite time. So over here, at the very starting of the program, we are not sure about the size of the array that we are provided over here. So the approach by which we have solved our previous problem, we cannot apply that approach over here because the length of the array is undefined over here. So by anyhow, we cannot find the median of a particular set of numbers by that approach. So we have to take some alternative approach to solve this problem. And that is why this problem is considered as one of the hardest problems during the technical interview. So let's start with solving this problem and let's see how efficiently we can solve this problem with least complexity. So over here you have to remember that for finding the median of a number, we have to consider 2 points. Number 1, the array that we are receiving should be in a sorted order. And number 2, the only way of finding the median number is to get the middle number or the middle two number for a particular array. But over here there is a problem that though these two are the main point or the main solution point of finding a median of a number, but the array that we are receiving as our input does not qualify both of them. But we have to solve this problem in such a way that both the conditions that are necessary for finding the median should get fulfilled. So let's see how we will do it. So one of the general solution or the brute force approach of solving this problem is, for example, we are getting this number as a streams of integer. So for example, at a particular instance, we get the first number that is 5. And after that, within a fraction of a second, we get our next number and that is 3. And in this way, we will keep on receiving one number at a time. So the brute force approach of solving this problem is we will store the number as soon as we receive the number from the input, and we will keep this number within an array. So for example, at the time instance t1, we get the first number and that is 5. And at the time t2, we get our next number, that is 5 and 3. So over here, as soon as we get the two number, we will create a computation, that is we will sort this number in the ascending order. So right now the array will become 3 and 5. Similarly, at the timestamp T3, if we get the next number, that is 2, the array that we have right now will become 3, 5, 2. And as soon as we receive the 2 over here, we will again sort this array to make it 2, 3 and 5. And in this way, as soon as we keep on receiving one number at a particular time, we will keep on sorting this array that we have over here. And at a particular instance, if we need the median of this stream of number, we can easily calculate the size of this array and we can find out the median number from here. So at this particular instance, the median of this array is 3. So in this way, we can keep on moving forward and we can solve this problem very easily. But if you see over here, the complexity of calculating the median will be high, because at a particular instance, we have to first capture the number in our array, and then we have to sort that array each and every time we are receiving a number from the streams of running integers. So at each and every step, the complexity of sorting this array will be order of n log n, which is the most efficient way of sorting a number. And since we are running this loop for n times, so obviously it will get multiplied with n and the overall complexity will be n square log of n. So though this is a possible solution to your problem, but this is not the optimal solution of this problem. So we have to make this solution a bit more optimized, and for that we will be using a particular data structure by which we can easily solve this problem. But keep in mind, we will be using this technique only to solve this problem. So to solve this problem in the most optimized way, we will be actually using an additional data structure for this. And the data structure that we will be using over here is a heap. So let's see first why we are using this additional data structure heap over here. So the way by which we are planning to solve this problem is quite easy. So what we will do, we will create two heaps, one as max heap and one as min heap. And if you do not know the real use case of the heap, so what heap does is, it is actually used to store a set of numbers internally in the form of a tree. So let's first understand that how a heap actually works internally. So for example, we have a few numbers. So let's consider this is one of a normal tree, and when we create a heap out of this tree and we perform a heapify over there, what it actually does in case of max heap, the number having the maximum integer value will be at the top. So for example, within this tree, the maximum value is of 8. So 8 will be the root element. After that, we have 7, then comes 5 and so on. So at a particular instance of a maximum heap, the top element or the root element will denote maximum number on a given tree. So I hope this makes sense to you that what is a max heap. Whereas in case of the min heap, the number having the lesser integer value, that is 1, will be at the top of the root, followed by the next number, that is 2 and 3 and so on. So over here, taking the advantage of the max heap and the min heap, we will be solving this problem. So this might seem quite confusing to you right now, but stay with me, it will be much more clearer when we will be done with our solution. And at that time, you will definitely see that this is the most efficient and the easiest way of solving this problem. So now, since you have understood that what is a max heap and min heap, let's now dig into this and let's see that how by using a max heap and the min heap, we can solve the problem of finding the median of our running integers. So over here at the very beginning, to solve the problem, let us take two heaps, one as a max heap and another as a min heap. The max heap will contain all the lower half of the numbers processed so far, and the min heap will contain the upper half of the numbers processed till that time. So over here, at a particular instance, if we are given some numbers such as 1 to 11, the lower half of the number, that is from 1 to 6, will go inside the max heap. And since this is a max heap, the root of the element will be the maximum number within this max heap. And the maximum number over here is 6. So over here, 6 will be the root of this max heap. Similarly, on the min heap, the rest of the number, that is the upper half of the integer series, will go within the min heap. So over here you can see that the number from 7 to 11 belongs to the min heap. And by the property of the mean heap, the smallest number within this set will be the root of the mean heap. So over here 7 being the minimum among this set, this will be the root of the mean heap. So now since we have understood that what is a mean heap and a max heap and how internally they will arrange the number, let's now connect that how this feature will help us in solving this problem. So over here if you see, if we are given a set of number from 1 to 11, you can see that to find the median of a number, we basically need the middle two element. So practically to find the median of an element, we need the two element at the middle, that is 6 and 7, which is nothing but the root element of the max heap and the mean heap. So at a particular instance, if we want to find the median of a running number, we actually do not have to consider all the other numbers that are within this series. Rather, we need to find out the maximum number within the max heap, that is the root of the max heap, and the minimum number within the mean heap, that is the root of the mean heap. So this is basically the two numbers that we need for finding the median of a streams of running integer if we can divide the running set of number into two equal halves within two heaps. And right now at this point, if we want to calculate the median of this series, the value of the median will be 6 plus 7 divided by 2. So this will be the answer of our question. So now here, since you have understand some basic concept that how we are going to solve this problem, let's now do a dry run of each and every step and let's see how easily we can find the median of a streams of running number. So over here, let us consider an infinite series of number. So the number we can see right now are 5, 3, 2, 7, 9 and 10. So there can be plenty more numbers behind this. So we are just considering or running our loop for this many numbers over here. So let's take an example that at a particular instance of a time, we get our first number and that is 5. And as soon as 5 comes to us as our input, the first thing that we have to determine is the position of the 5 within this two heap. That means that whether the 5 will go into the max heap or the 5 will go into the mean heap. So by distributing the numbers properly between the two heaps, we can easily find out the median in a very optimized way. So to find out the exact position or the appropriate position of the 5, what we have to do, we first have to check the root of the max heap. So over here, since the max heap is empty, so we will blindly put 5 within the max heap. And since 5 is the only element within the max heap, so obviously 5 will be the root element over here. And over here, between the two heap, that is the max heap and the mean heap, since the number of element within the max heap is more than that of the mean heap, so the median of the number will be the root of the heap which contains the maximum number of elements. Which means that over here, since the max heap contains one element and mean heap contains 0 element, so the median of this series right now, which we have encountered till now, will be the root of the max heap. So I hope this is clear to you. Now let's consider the next number that will be coming as our input. So the next running number will be 3. And over here again, we have to place this 3 into our correct bucket. That is, it should go either in max heap or in mean heap. So to understand that whether it should go to the max heap or mean heap, we again have to check the root element of the max heap. So the root element of this max heap is 5. And over here you can see that the number that we have encountered right now, that is 3, is less than 5. And since over here the value of the 3 have lesser integer value than that of the root of the max heap, so obviously 3 belongs to the lower half of the number and the correct position of the 3 is on the max heap. So we will put 3 into our max heap. But over here there is a problem. After the insertion of 3 into our max heap, the 2 of the heap got unbalanced because there is a difference in the size more than 1. So which means that right now the two heaps are unbalanced, and our main objective of this problem is to keep the two heap balanced at each and every moment, and the size difference between the two heap should not be more than 1. So right now our objective will be to balance these two heap. So how we will do it? We will pop out the root element having the maximum size. So over here the max heap has a greater size than that of the mean heap. So over here we will pop out 5 from our max heap and we will put it into mean heap. And thus our two heap gets balanced over here, and you can see that the root of the max heap is right now 3 and the root of the mean heap is 5. So hopefully it is clear that how at each and every instance we will be balancing the two heap if there is a condition arrive that our heaps gets unbalanced. And once this heap get balanced after the insertion of the new number, that is 3, we have to find out the median of these two numbers. And the median of these two numbers, since they are equally balanced right now, will be the root of the max heap, that is 3, plus the root of the mean heap, that is 5, divided by 2, and thus it will result into 4. So right now 4 is the median of two numbers that we have encountered till now. So easy, right? Let's iterate with few more elements over here so that you will get the concept very easily and you can easily solve this problem during your interview. So let's consider the next number, that is 2. So as soon as 2 arrive as an input, we first have to determine that which bucket it will go. And to check that which bucket it should go, we first have to compare this value with the root of the max heap. So over here, the root of the max heap is 3. And since the value that we have encountered, that is 2, is less than 3, so obviously it will be the part of the max heap. And that is why we will put it within the max heap. And over here we have to again check that whether the two heaps are balanced or not. So here the difference between the size of the two heaps is still 1, which means that the two heaps are right now balanced. So the only condition you have to remember at which the two heap will get unbalanced is when the difference between the size of the max heap and the mean heap will be greater than 1. So let's now find the median of this set that we have encountered until now. So after the insertion of the 2 over here in our heap, the median will be 3, because according to our condition, if the size of the two heap are not equal, then the median of this set will be the root of the heap which have the maximum number of elements. So over here, since max heap has more element into it, so the root of the max heap, that is 3, will be the median of this number series. Let's consider the next number, that is 7. So again we have to check with the root of the max heap to determine that in which bucket 7 will go. So over here, after comparing, you can see that the value of 7 is more than that of 3. So obviously 7 belongs to mean heap. And over here, after the insertion of the 7 in the mean heap, you can see our two heap is still balanced. So we have to calculate the median at this point, and the median of this running set right now will be the average of the root of the max heap and the mean heap, which is 4 right now. So hopefully until this point, this concept of insertion and balancing these two heap is clear to you. Let's do the dry run with two more sets, that is 9 and 10. So let's consider that on the next iteration, we get the element 9 over here. And obviously after comparing it with the root of the max heap, you can easily determine that 9 will belong to the mean heap container. And over here, after the insertion of 9 into our mean heap, our two heaps are still in a balanced mode. So we do not have to implicitly balance the heap over here. So what we have to do? We have to find out the median until this point. And the median will be 5. That is the root of the heap having the maximum number of elements. So let's now consider the last and the final item of our running series, and that is 10. And over here you can see by comparing it with the max heap, the value of the 10 will go within the mean heap. And over here you can see that after inserting 10 into the mean heap, our two heaps gets unbalanced because the size of the mean heap is 2 more than that of the max heap. So over here we need to balance this 2 heap one more time. So what we will do? We will pop out the root of the mean heap and we will push it within the max heap. And again we will heapify this 2 heap so that we get the maximum number from the max heap and minimum number from the mean heap, which results into our median value. So hopefully this is clear to you that how easily by using the 2 heap we will be solving this problem at a particular instance of time. So the primary goal of solving this problem is we have to insert the particular input into its correct bucket, and we have to keep on checking that whether the size of the bucket are balanced or not. And if the two heaps are not balanced, we have to balance them manually and we have to find the median of the numbers we have encountered until that point. And to find out the median of the number, the calculation is pretty easy. So if the size of the two heap, that is the max heap and the mean heap, is equal, then the average of the root of the max heap and the mean heap will be the value for the median. And if the two heaps are not balanced, then the root of the heap having the maximum number of elements within the heap will be the answer to our median value. So hopefully you guys have thoroughly understand the logic of how to solve the median problem over here. And if you have liked the solution, please do like and share this video. And if you are new to my channel, don't forget to subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are ready for your next interview. So without wasting much time, let's start with the implementation of this algorithm using the Java code. So see you with the implementation. So let's start solving this problem. So over here you can see to solve this problem, we have just created a class file called as running median number. And over here I have just created a simple main block from where I have a series of number and I am passing this number into a function where we will be implementing our logic of finding the median number. So let's start writing the algorithms over here. So there can be a plenty of solutions that you can easily find on the internet for this problem. But over here we will be solving this problem by the same approach by which we have visually explained the solution. Because with that approach it will be very easy for you to recollect the solution during the interview process. Otherwise, if you try to mug up the solution from any of the sites from internet, it is very likely that you will forget the solution during the time of interview. So let's start with solving the problem in the same easy way by which we have visually solved the problem. So the first thing that we have to do over here, we have to create two heaps. One is the max heap, which will consist of all the numbers that comes on the lower half of the series, and one is the min heap, which will contain the upper half of the series. So let's create two heaps over here, and the easiest way of creating heap in Java is by using the priority queue. So let's implement the two heap over here. So the default behavior of a heap is the min heap, which means that in a heap, the element having the lowest possible value will be at the top as our root element. But if you look carefully over here, our max heap needs the maximum number at the top. So we have to reverse the default logic of our max heap. So what we'll do, we will reverse the sorting logic over here. Now let's start with the implementation of our algorithm. So the first step of our algorithm is, since 5 is the only number in our integer series, we will blindly put 5 into our max heap. And since 5 is the only number over here, so obviously the median of the numbers that we have encountered until now will be also 5, which is nothing but the root element of our max heap. So I think this is clear to you until this point. Now let's start with our main program of iterating over this loop. So to iterate over this array, we will be using the for loop over here, and we will be starting from the second item of our array, that is 15 over here. So if you have understood our algorithm carefully, our algorithm have three basic parts. One is the insertion, that is inserting the correct element at the correct bucket. Number two, balancing the unbalanced heap. So if our heap gets unbalanced during runtime, we have to balance the heap. And number three, we have to find the median of the elements we have encountered so far. So let's start with the first process, and that is insertion. So let's consider that the first number that we have encountered over here is x. And we have to determine that whether x will go into our min heap or into our max heap. So over here we will check this condition. So if the value of the x is less than max heap, which means that the element x will also go within the max heap. Otherwise, it will go into our min heap. I think this is clear to you that how we are determining the position of a particular x value within our heap. Now we have to check that after the insertion of an element, whether our two heap gets unbalanced or not. So there can be a particular way by which the two heap can get unbalanced. So if the size of the max heap is greater than that of the min heap by 2, then we will consider it unbalanced, and vice versa. So over here we will check that whether the size of the max heap is greater than the size of the min heap by 2 or not. So if the size of the max heap is greater than the min heap, which means that the number of elements within our max heap is more than that of the min heap. And if the size of the max heap is greater, what we will do, we will pop up the root element from the max heap and we will put it within the median. Similarly, we will check if the mean heap is greater than the max heap by 2, we will put the value of the mean heap into max heap. So hopefully this logic is also very simple and easy to understand. So first what we are doing, we are first inserting the value into the correct bucket, and after the insertion, if our bucket gets unbalanced, we are balancing it over here. Now we are left with the last and the final step, and that is finding the median. And the logic of finding the median is also pretty simple. What we have to check? We have to check that whether the size of the two heaps are equal or not. And if the size of the two heaps are equal, then our median will be the average of the two roots from our two heaps. So we'll calculate the median over here. So let's define the median at the top. And if the size of our mean heap is not equal to the size of the max heap, the other possible way of finding the median is the value of the median will be the root of the heap having the maximum amount of element inside it. So let's implement that logic. And at the end over here, we will print out the median that we are getting at each and every iteration. So let's print the median over here. So let's click on save and let's run this program and let's see whether we are getting the correct output or not. So let's run it, and great, you can see over here we got the required solution. So let's do a dry run over here and let's see whether the answer that we are receiving is correct or not. So let's consider the first number, that is 5. So when we are receiving the 5, our median is also 5. So that is correct. Now we are receiving the two numbers, that is 5 and 15. And when we are receiving 5 and 15, the median will be the average of these two, which is 5 plus 15 divided by 2, which is 10, which is also correct. Now let's consider the next element, that is 10. So right now in our bucket we have 5, 15 and 10. And the median of these three numbers will be 10. Let's consider the next, that is 20. So when we have this four number over here, the median will be the average of 15 and 10, which is nothing but 12.5. So over here you can see that on each and every iteration we are getting the correct median value over here, which means that our algorithm is working brilliantly. So I believe you guys have thoroughly understand the way by which we have so easily implemented this algorithm over here. So if you have any doubt regarding the implementation of this algorithm, feel free to let me know in the comment section below. I will be happy to help you over there. And if you want to go through this code, feel free to do that. I will be providing the code snippet in the description below. So hopefully you guys have thoroughly understand the video, and if you have liked this video, don't forget to like and share this video, and if you are new to my channel, don't forget to subscribe and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So see you guys on the next video with another problem from Technical Interview. See you in our next video. Thank you.